Hello viewers, welcome back to our channel. This is Math in Motion. Today we are going to go ahead with our stochastic processes, our second video, and today we are going to talk about our sample question. The sample question is like this: consider a simple random walk. We saw last time a simple random walk what it is xt equals to xt minus 1 plus zt, where z is the increment and the increment is described as 1 with the probability of p and negative 1 probability of 1 minus p. Now our question wants us to calculate the probability of x2 equaling to 108 and x5 equaling to 104 given x0 is 100. Then the second part is first to calculate the probability when x3 is 0.012 and x6 is 104 when x0 is 100. And lastly, want us to find the expected value of zi. Want us to find the expected value of our increment. Part B, they say now suppose our x0 is 10. I want us to sketch all possible paths to x5. And then want us to find the probability of x4 equal to 13 given x0 equals to 10. Lastly, the question is saying, is this simple random walk a non-stationary point? Is this non-stationary or what is stationary? They want us to prove. And lastly, they want us to show that does this process above have a Markov property? Then I think today we shall just go through about this question and we see how we can answer this question relating to our first video we did last time. Okay, I think let us begin with part 1 and part 2 and part 3 as we shall be going down. I think let me first put off this so as we can get space where to work from. Now, me putting off this first to remain with only the part 1 and part 2 and part 3. I think also this part 3 I can put it off. Let me begin with this number. Calculate this one. As we said that we shall always sketch for clarity. We shall need to always sketch. Ella, I'm going to sketch something for you as we did last time. I think you remember. We sketch, but now our x0 is 100. Therefore, we must sketch something like this. My triangle will not be like this. But our x0, we are beginning with 100. Now here it is 100. Remember, this is our xt. This is our t. They said our x0 is 100. Then I'll have more. This is going to be 101. Here I'll have 102. I will have 103. I will have 104. Then I will have lastly like 105. 105. And then I go down. I will have 99. I will have 98. I will have 97. Then I think let me stop at 96. Those are my values of xt. And then now here I want to get my values of t time. Now from here I'm seeing that my question has x5, x3. Therefore I have to go up to xc, up to t6. Now if I say that if I begin with my t to be 0 here, and then it's going to be 1, 2, 3, 4, 5, 6, then 7, like this. Now that let us get the probability when x2 is 102 and x5 is 104. Now if our starting point is 100, how can we go about this? Now we are saying beginning from 100, we either increase by 1 or reduce by -1. At 100 here, I'm having here at this point here, I'm either moving up by 1 like this or moving down by 1 like this. Yes. Then at this point again, I'm going to move up by 1 like this or move down by -1 like this. And the same thing is going to happen here and here. The same thing is going to happen here and go like this. As we said in the last video, here and here, then here and here, up to when I reach at my x equals to 6 here, I'll move up like this, then move down, move up, move down, move up, then move down, I move up, I move down. Up this point here, I have to move up, then move down, I move up, I move down, I move up, I move down, I move up, I move down, and then also here I have to move up, then I think also move down. If I try to include another table here, if I try to expand this to 95, and then include something here up. But now I think for this first question is going to be enough for us. Now look here. Let us look at this thing we have done. Now saying that our x naught is 100. I'm being 100 when t is 0. I have 100 here. I'm either moving up or moving down. But I think that x2 has to be 102. Now let's talk about our x2. Our x2 is this value here. We're talking about the value of x2. Our x2 has to be 102. Now, if I come at this 2 here, I come up here, my x2 is 102. At this point, what they want us to say. Our x2 is 108. Our x2 is 108. This is the value they want, which is right. But now, our x5, they want it to be 104. Therefore, first to reach at this x2 being 108, I will just move up like this. You have no possibilities of reaching here. Just moving up like this. From here to here, then from here to here. That's when I reached to x2. But now your x5 to be 104. How is it going to be? My x5 is here. 104 is going to be at this point here. You are seeing since there is no route that will lead me to this point here, 104. This is 103. This is 104. My x5 has to be 104. This is my 5 here. Since there's no route that will lead me to this 101, because now remember I'm coming at this point, then this point, from this point then to this point, then to this point. But now there's no route that will lead me to this point here. Therefore, the probability of me reaching here is 0. Are we together? I will come from here up to here, but there's no chance of me being at this point 104. Therefore, the probability of being here, x5 being 104, is 0. Therefore, we just conclude that the probability of me reaching here is 0 because there is no route that will lead me that will lead my x5 to be 104. I'm saying it is 0 because there is no route that will lead me to my x5 to equal to 104. Because I'm seeing that 104 is along this. Sorry, x5 is along with this. This is my 5. This is my x5 now. Here is 104. And I'm seeing my 104 is not either here or here. Therefore, the probability of me reaching here is 0 because I have no route that will lead me to this 104. Likewise, we can do the same thing for x for this part. Now for this part, where the difference comes in for this part now, part 2. Now for it saying that x3 it has to be equal to 102. Now if I come to my x3, remember this is my t, this is my xt. Now if x at 3 it has to be 102. Now if I come here at x3 here and I look up here, I have to have my x3 equaling to 102. But now if I look critically from at this point here, this is my x3, this is my 3, then this is 102 is going to be here. What we are seeing, 3 and then x3 is going to be at this point here. Now for the start, this x3 because 102 has no route that will lead me to this point here. Or am I clear on what I'm saying? I'm saying that since this x3 has to be 102, and 102 is at this point here, because this is my 3, then this is 102, which is at this point here. And there is no possible route for me to take on to reach at this point 102. Therefore, the probability of me reaching here is going to be 0 because I have no route that will lead me to this point here. Therefore, also I will conclude that this probability of x3 equals 102, given x6 equals 104 is equal to 0, with the same reason that there is no route that will lead me to x3 equal to 102 at this point here. I think that question we are okay. For any increment or questions, please utilize my comment section. I will be able to answer. But I'm just saying that since we have no root that will lead us to x5 being 104, as we have seen that for x5 is here, 104 is here, therefore the instruction is here. There's no root that we shall take for us to lead us that my x5 to be 104. Therefore, the probability of having x5 equal to 104 is 0. Therefore, I will say that this is the same as having 0. The whole of this thing is going to 0. Now, for this part again, x3 being 105 is impossible because I have no root that will lead me to this point here, x3 being 105. So 102. So since there's no root of me having this one, therefore the probability of having 102 is 0 for these two points here. And I think even I had the other reasons you have given on that point. I think I should put off this. We are together on that point. Now the other part was me to find the expected value of zi, which we did last time even, but you can also repeat it in this video. The other part was for us to find the part 3 was for us to find E of zi, which is the same thing as having zi times f of zi summation. Yes. Now, what is zi? Z1 is 1. The probability of having z1 is p. Then plus, what is z2 is going to be negative 1 minus p into 1 minus p. That way. Then if we add them, we shall have 2p minus 1 as our zi. I think we call this one. This one was the simplest. Now, for the part C, for the part B of the question, was telling us now. They said suppose x naught is 10. The part B of the question was saying suppose x naught is 10. Now they want us to calculate the probability. They want us to sketch all possible parts of x5. That's part they were saying to sketch all possible parts, of x5. I think now here we shall need to have a bigger space for us to illustrate this thing. Now, for me to sketch all possible parts of x5, what I need to do is to have a bigger space like this. Let us have our drawing first. Shall have our drawing first. Now remember we have our x naught is 10. I begin with 10 like here in the middle. Then I'll have 11. I'll have 12. I'll have 13. I'll have 14. I'll have 15. I'll have 16. I think I'll have okay, let's stop on 16. This is my xt. Then I'll come down here again. Here to have 9. To have 9, 8. To have 7. To have 6. To have 6. Then 7. This is 5. To have 6. And then I think to have 5, 6, then this is going to be 4, and then after 4, 3. Then if we stop there, then now let us try to sketch for the values of t. If this is 1, 2, 3, 4, 5, and then 6. But remember, they want us to have the possible parts of the x equals to 5. Now, if this is going to be if this is 0, 1, 2, 3, 4, 5, and then a 6 this side, and then our x naught is going to be 10. Then I'm almost moving from x naught, which is 10. I can move up by positive 1 like this, or move down by positive 1. That's the first step there. Now, when I move here up again, I can also move by positive 1 up or move by positive 1 down, by negative 1 down like this. I move up, then I move down again. This is my x2. For me getting my x2. Then from that step again, I can either move up or move down. I think let me continue using the same color. I can also move up or move down. I move up, I move down, I move up, I move down. Then for x4, I can do the same. From x3 to x4, I either move up or move down. I 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 think that's going on that step again. Then from x4 to x5, I also move up or move down. I can move up or move down. I 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 move up or move down. And then these points are the points that will give me various values of x5. These will be my xt when x is 5. So when my t is 5. Now they want us to show this is the possible route for me to get the x5. The probability of me having x5 equaling to 15, equaling to 13, equaling to 11, equaling to 9, equaling to 7, equaling to 5. Therefore, the probability of x5 equaling to 6, since it is here, it is 0 because there's no route that will lead to me having a 6 equaling to 0. x6 equaling to 6. Now, from that step there, I think we know that if we're moving up, it is a positive p. If we're moving down, it is 1 minus p. Now, let us look at on how to get the probabilities when I'm at this point. Let me even put off this for us to have space where to work from. Now, I want to allocate probabilities of these different routes we've taken. In the past video, we did for only 3, but now in this particular question, they want us to do up to 5. Last time we did up to 3, but now they want us to do up to 5. I think we can read it together. Now, for me getting that my probability of x5 equaling to 15 is going to be this part here. How do I reach this part here? I just move. I move up, move up, move up, move up, move up 5 times because this is p, this is p, this is p, this is p. I'm moving up. This is p. Therefore, I'm going to have just here as my probability will be p power 5 because I'm moving up like this. That's the only possible route I can take for me to have this. Are we together? Now, also, my probability of x5 to be equal to 5 at this point here is just for me moving down. The possible route I can take is just moving down like this, like this, like this, like this, and like this. Therefore, my probability of x5 equaling to 5 is the same as having 1 minus p power 5. I think those are the simplest to first deal with. Now, the second part now is first to determine that the probability of x5 equaling to 13 at this point here, given x0 equals to 10, is first to find the probability going to be here. Since we shall look at all ways of us reaching at this point here. Now let us begin. The first way is for us moving like this, from here to here, to here, to here, to here, then coming down like this. Is p times p times p times p times 1 minus p. No, that's the first thing. Then I can write it, I think. Why I put a different color? It's the same, like this. Moving up, I move up, I move up, I move up, I move down. That is having p power 4, the same as having p power 4 into 1 minus p. The first thing. For me to reach there. Now, my other attempt to reach here, I can come like this. I can move up, I move up, I move up. At this point, then I come down, I again move up. Whenever I move up, it is positive, it is p. Whenever I move down, it's 1 minus p. Therefore, I have this one plus this one, p times p times p times 1 minus p times p, which is the same as having plus p power 4 into 1 minus p. Now together. Now, the other attempt for me reaching here, I can come like this. I can come like, can be like, this is going to be p, then I come p again, I move down, I come up, I come up. I have p times 1 minus p times p times p. It's the same as having plus p power 4 into 1 minus p. Well, are we together? Then my other attempt of me reaching here is going to be in this way. I may come from 10 to this point. Then I move down here. Then I go up, up to when I reach this point there. Therefore, also that is the same as having p times 1 minus p times p times p times p. It's the same as having p power 4 into 1 minus p. Yes. Now the last attempt is me now coming from here. From 10, I just move down like this. Then I keep moving up. Now this is 1 minus p times p times p times p times p, which is again p power 4 into 1 minus p. Our answer is going to be 5, because if I add everything here, I have 5p power 4 into 1 minus p. Yes? Yes. Now, now for this point and this point and this point, we can also still do them. Going like how? Moving, I move down again. And I shouldn't reach this point. I'm moving. I'm saying like this. I come here like this, like this, like this. I'm not moving backwards. I'm moving forward. Are we together? Members, I'm moving forward. I'm not allowed to move backwards. That's why I'm moving forward. As in this time period, I'm moving forward. Xt has to go than S for a random walk. I'm moving forward. Time is continuous. I'm moving forward. I'm not allowed to move backwards. That's why I'm saying that if I come from 1, I have to go exactly to 2, not going back to 3. That's why we go that step of mind to be 5 power p, 5 p power 4 into 1 minus p. Now let's go again and we see how we can obtain this path here. This path here is going to be a bit tricky, but you have to get it. Because I'm seeing that there are many possible ways of reaching x power of reaching x5 to be 11 here. But now we can still go about it. How? Let us begin to see how we can reach this point here. Now, for me to reach at this point here, I can begin from here. I come up, I come up, I come up, I move down, I move down. That is my first attempt. It is now p times 1 minus p. This is going to be, here I have p cubed into 1 minus p, like that, squared. That's my first attempt. Now, my second attempt may be, remember, my task is reaching here. Maybe I can come up. I come up the second time. I move down for the first time. I come up the third time. I move down the second time. Are we together? I'm saying I come up. I move down for the first time. I come up again. Then I move down. That's the same thing as having p cubed into 1 minus p squared. Now that is my second attempt. Come like this, like this, like this, like this, like this. Now my other attempt may be, for me coming from here, I come up, I move down, I come up, I move down. That is going to be my third attempt. P3 into 1 minus p squared. Now my other attempt may be, for me reaching here. Remember I've said the third attempt is coming from here to here to here to here to here. My attempt may be, for me coming from here to here, to here, to here, to here, then back to here. I think that's my fifth attempt. I'm saying, for me to reach here, the first thing we say that it's coming from here to here to here to here to here. Then now I come down up to here, this point here. My side is also coming from here. I come here. I can move down. I move up. I move down up to here. My first is going to be coming from here to here to here to here to here up to here. Now my fifth attempt is going to be coming from here to here to here. I move down, I move up, I move down, I move up again. Now see, it is positive, sorry, p times 1 minus p times 1 minus p times p. It's going to be p cubed into 1 minus p squared. Remember, I want us to be together. Now, Then that attempt may be now. I may begin by moving down. I can move down, moving down. I move up. I move up. I move up. I move down. That is going to be plus again p squared into p cubed because I'm moving up thrice. I'm saying I'm moving down. I move up. I move up. I move up. I move down. I'm moving down twice. 1 minus p squared. Now the other, which may be, I may move up, move down, move up, move up, move down, then move up. I may come like this. Who, 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 who. Yes, I'm saying that I may come like this. We've said that this one wrote it from moving up. I move up, I move up, I move up, after I get this point here. But now I may come like this. From here to here, to here, to here, to here, to here. I'm moving up thrice, I'm moving down twice. Same plus p cubed into 1 minus p squared. Now the other attempt may be, I may move down twice like this, from here to here, then to here. I'm moving down, moving up, moving down. I move up once, I move up twice. Okay, I'm moving up thrice, I'm moving down twice. I'm coming from like this. Who. After I reach that side, that's the same as having p cubed into 1 minus p squared. And then 1, 2, 3, 4, 5, 6, 7. Now the other attempt may be me coming like this. I move down, move up, thrice, plus p cubed into 1 minus p squared. I'm moving down twice, then I move up, thrice. Yes. Now the other attempts may be, what have we left out? I may try to move in the format like I move down, I move down again, I move. I'm saying this one we finished it. We have to have 10 attempts of this thing. This is 1, 2, 3, 4, 5, 6, 7, 8. Now other two. Say the first one is coming like this. 1, 2, 3. So they're coming here. 1, 2, 3, 4, then a 5, then a 6. Sorry, like this. 7. 7 is coming like this. 8, 9. Then the last one is coming. They have to be 10. Yeah, I think you've seen this one. You've not counted this one. This one coming like this, then like this, then I move down, I move up, I move up. They have to be plus, and then a plus p cubed into 1 minus p squared. Now, for I think you've seen the way we've done this thing. In order for us to have the 10 things, I'm looking at all possible routes I can take for me to have to be here. Therefore, for reasons of being short, therefore I have to say that at this point here, I have 10 p power 3 into 1 minus p squared. Then likewise here, now for this point, it's going to be your exercise. You have to check whether this is the same as having, yes, 10 p squared into 1 minus p cubed. This is your exercise. You have to check and see whether the probability of x5 equaling to 9 is this value, and then also you have to check whether this the probability of x5 equaling to 7 is 5 p into 1 minus p or 4. That is your assignment to do. But this is the way we had to do this question, and the question was asking us to sketch the possible parts of x5. These are the possible parts of x5. We will do this one as we did this one to check whether this is right, and then we will do this one as we did this one to check whether this one is right also. Now, then for part B, for part B, it was asking us to find the probability of x4 equal to 13 given x naught. Part B, Roman 2 was telling us to find the probability of x3 equal to 14 given x naught equal to 10. As we said, we just locate along our diagram we drew. We say that x3, where is x3? x3 is here. Can x3 be 14? Where is 14? 14 is here up. Sorry, it was 13, not 14. It is 13. They say now probability of x3 equal to 13. Our 3 is here now. X3 is being 13. I move up to here. Is it? Now let's find the probability of x3, x4 equal to 13. I'm saying x4 equal to 13. This is our 4. Now x4 equal to 13. So it should be at this point here. Since there is no rule that will direct us to this x4, to this x4 being 13, yes, the probability of this one equal to 0, because there is no rule that will take us to x4 being 13. Because 13 is here, there's no rule to take up to this point here, equal to 0. And I think for that part we have finished doing it. Now for the other part, we shall let us continue for the other parts, but let us first take a break and then we shall see how we do the other parts. I think I've tried to expand everything for you. Just take time and redo this one and see how we get this 10p cubed 1 minus p squared, and then you do this one to say 10p squared into 1 minus p cubed. Then you do this thing as we did here. Then this 1 minus p, I think, is the easiest. Just moving down, just moving up, p power 5. Yes, members, we come back from a short break. I think we have seen that our question was: is this process random walk? Is it a non-stationary point? Then we have to include the proof. Now, yes, you have to note that stationarity of a process implies that the distribution of xt plus k is identical of xt for all values of t, i.e., the probability of xt plus k equals to x is the same as having probability of xt equal to x. The example is like the probability of me having, remember our xt, your t may be 1 and your k may be 1. Yes, it is saying that probability of xt, if your xt is 1 and k is 1, I have x2 equal to a certain value, 102 has to be the same as the probability of x. Remember our t is 1 equal to 102. This thing has to hold for, I'm saying the probability of me having both of these two have to hold for something to be stationary. Okay, in the layman language is that for a process to be stationary, the distribution of xt plus k has to be the same as the distribution of xt. If you take an example when t is 1 and k is 1, therefore my xt plus k is going to be x2, and then this value of x has to be 102. An example of 102, and then this xt has to be the same as 10 xt. Our t is 1, is going to be now x1 equal to 102. Now these two has to be equal for it to be identical. But now we saw in our previous question, from the question we did there, we saw that the probabilities are not equal because the probability of x2 being this one, we saw it as being p squared. For me moving up twice, it was p squared, and then probability of my x1 to be this one was 0. I think we recall. Therefore, since those two are not equal, therefore these two are not equal, because remember we do our thing like this. This is 100, 100, 101, 102, like this, then like this, then like this. Now, they say that this means that for us, we're looking about x is 0, this is 1, 2, and then 0. I'm looking at the point when x2, if I move up once, then twice, my x2 can be 102. The value of me having x equal to 102 is p times p, which is p squared here. Now, the probability of me having x1 equal to 102 x1 here, just talk about 1 0 2, because 1 0 2 is this point here. It's outside. I have no that will take me at this point here. Therefore, the probability of me having x1 as 0.2 is 0. Therefore, for just a mere looking using this just mere observation, this system, this process is not stationary because the probability of x2 is not the same as the probability of x1 having the same values of x. But now, the easiest way for us to check whether the probabilities are equal is for us to check whether the mean and the variance of the system of the process are equal. Yes, actually are time dependent or are invariant. I'm saying that for us the easiest way to check whether something is the process is stationary is for us to check whether the system is for us to check whether the mean and the variance of the process are time invariant, i.e., they are independent of the time. However, if the mean and the variance of the process being, however, when the mean and the variance of the process are time invariant or are independent of time, does not mean that the process is stationary. Just it means that the process is weak stationary. Now, in our previous video, we saw that the mean of a simple random walk is just having t into 2p minus 1, and the variance of the simple random walk we say having t into 4p into 1 minus p. And we say that the mean will always depend on the time, and then the variance also will depend on the time. Now, since these two are depending on time, therefore they are not time independent. Yes, they are not time independent or time invariant. Therefore, these two, since they depend on time, then we shall just conclude that since the mean and the variance of our simple random walk are time invariant or time independent and non-time invariant or time independent, the process is a non-stationary point because these two, our mean and the variance, they depend on time. They are not time independent. And for this, I think I've tried to explain properly. For any questions, just feel free to put the comment section. And members, always like my videos. It has nothing for you to press the like button and share the video to other people so as to enjoy. Now, for the other question, it is in this format. We want to show that whether the process follows a Markov chain, a Markov property, whether it satisfies a Markov property. Yes, members, I think for the last question, it was telling us to explain whether our simple random walk contains a Markov property or has a Markov property. But you just need to note that we only need to prove that the process has stationary increments and a Markov property. But remember, always remember that independent increments imply a Markov property, but the Markov property does not imply independent increments of the process. Therefore, you should be sober. If you have a process which has independent increments, therefore it means that that process contains a Markov property. Then, since we have that our increments, zt is 1 and negative 1 for p and then 1 minus p. And then one of the properties to say that zt is independent of zs. Therefore, these increments are always independent of each other for a simple random walk. That only will explain to us that will explain to us that our simple random walk is always contains a Markov property because it has independent increments. Thank you for watching this video for today, and I take this opportunity to thank people who have tried to support the channel. Thank you, Jeremiah. Thank you, Angie. Thank you everyone. People who have contributed to the growth of this channel, I thank you. And members, keep watching the videos, share them to many people as possible, and keep liking the videos so as to keep me engaged in the video. I'll be happy when I see some comments, because those comments also keep me pushing to provide the best to you. Yes, don't forget that this coming week we are voting for Nankabira Bridget for debate union representative Cobams. Therefore, on Wednesday, make sure you press that button for Nankabira Bridget blessing so as to be our Debate Representative Cobhams. Thank you for watching. I remain Shaka Anwar, the math tutor.